All right, let's solve for x. Or solve this equation for x. It's trigonometric function for x, or equations. 3 sine of x minus 2 equals 5 sine of x minus 1. Basically, we're going to try to isolate the variable. So let's subtract minus 5 sine of x from both sides. So I have 3 sine of x minus 5 sine of x. I'm going to add the variables to the right side. So I'm going to subtract minus 2 from both sides. And so minus 2 gives me a positive 1 on the right side. 3 sine of x's minus 5 sine of x's gives me a negative 2 sine of x's equals a 1. Divide both sides by a negative 2. Sine of x equals 1 minus negative 1 over 2. Divide both sides by a sine. Sines cancel out, so I have x equals negative 1/2 over sine. Whoa, guys, yeah, stop the presses there. We're not solving for x, we're solving for sine of x, because you can't solve for x by itself. So let's back up a little bit. Let's just put a big old cross mark on that, and let's never make that mistake ever again. So let's back up. And so we're just going to go back to sine of x equals minus 1/2. So what are my solutions that equal that? Well, the solutions are, that would be the sine of pi 6 equals minus 1/2, or equals 1/2. So I know the sine of pi, okay, the reason why I did that, the sine of pi 6 equals 1/2. And however, I'm looking for places where the sign is negative. So I kind of have to remember which quadrants the sign is negative in. Sign is negative in the 3rd and 4th quadrants. So if I look at this basic acute angle, that I know that the sine of pi 6 equals 1/2, where on my period between 0 and 2, pi, does this result in a negative sign? It does in the 3rd and 4th quadrants. So how do I skip from pi 6 to its negative counterpart? Well, one way to do that is to figure out what's its sign value in the 3rd quadrant. So pi 6 plus add a pi to it puts it in the 3rd quadrant. So let's go ahead and solve that. Pi over 6 plus 6 pi over 6 equals 7 pi over 6. So I know the sine of 7 pi over 6 equals negative 1/2. I know you might have to stop and rewind and do this one again, because what in the world did he do here? Sine of x equals negative 1/2. Then all of a sudden he just changed to the sine of pi over 6 equals 1/2. Well, the reason why we did that is I want to find out what is its basic acute angle, usually in the 1st quadrant, that produces a sine of 1/2. If I understand what that is, then from there I can figure out where does the sign become the negative of the value. And so one way to do that is I can add pi to that. Adding pi to that puts the angle over in the 3rd quadrant. So I have a solution of 7 pi over 6. But I know they have a solution in the 4th quadrant as well, because the sign is negative in the 4th quadrant. So how do I get from there? Well, if I have my basic angle over in the 1st quadrant, let's subtract 2 pi from it. It's going to bounce it down there. So I can take 2 pi minus my acute angle, pi over 6, solve that out. That becomes 12 pi all over 6 minus pi over 6 equals 11 over 6 pi. So there are the 2 solutions that make this true. The sine of 7 pi over 6 equals 1/2, negative, and the sine of 6 pi equals minus 1/2. So those are my 2 solutions to this equation that occur within the period 0 to 2 pi. But because we know that this is a cyclical function, the solutions are infinite, meaning that I can find the next solution by adding 2 pi to it, adding 2 pi to it, and so forth. Let's take this solution, 7 pi over 6 plus 2 in pi. And that will give me all of its solutions that are off by 2 pi on this one. Plus this one is 11. Why don't I keep doing that, folks? 11 over 6 pi plus 2 in pi. So there are all my solutions that make this equation true.